Hi, good afternoon, ladies and gentlemen. Welcome to WeLynx webinar on Indonesia wind energy project and technology development. My name is Lynic Wang, partner of WeLynx, and I will be the moderator for today's session. Thank you very much for spending time with us for joining our webinar today, and we are very glad to have more than 220 registrants for today's webinar. And I saw that we have got quite a few people already online, so let's get started. I'm very glad to introduce you three distinguished speakers today. Mr. Benoît Prim, Technical Director from SL Engineers. Mr. Arka Wiriadidjaja, Director of Market Development, GE Indonesia. Mr. Leonard Yeo, Managing Director, Renewable Energy Global Solutions from Singapore. Our total duration will be 1 hour. The three speakers will share their presentation and insights for 10 minutes each, and followed by 15 minutes Q&A sessions. We have collected from pre-registration, and we also collected some of them from the floor. All right, I saw most of the registrants has already signed in, so I think it's time that we can welcome our first speaker from GE, Mr. Arka Wiriadidjaja.
Thanks, Lynic. So share my screen. Let me know if you can see my screen.
Yes, we can see it.
Okay, all right. So thanks, Lynic, and hi everyone. Depending on where you are, good morning, good afternoon, and hope everyone is safe and well. As introduced by Lynic, my name is Arka. I am the Market Development Director for GE in Indonesia. I am looking after all of the business actually, from aviation, healthcare, power, and also renewable. So perhaps a quick introduction of GE if some of you are not very familiar about it. So GE is a 125 plus years company with 300,000 people globally, focusing in power, renewable, aviation, and healthcare. And in Indonesia alone, we have around 1,400 people, strong local talent and strong local presence, looking after all of the businesses with several footprints as well for manufacturing and service facilities in the country. All right, so when it comes to renewable, I believe we are seeing the same trend globally, right? A renewable market evolving at unprecedented pace, with wind and solar growing among the fastest, hitting the grid parity in several locations. Well, it's a good sign to show that wind and solar are now a competitive source of energy, and we can together grow the business in Indonesia as well. We in GE are working closely with the market to make sure that we are aligned in the market and also to grow the sector together with our partners. We are doing several renewable power plants actually. So from solar, wind, hydro, hybrid, battery storage, with a scope ranging from co-development. So by chipping in equity, development expenses or DevEx, providing equipment, turnkey wrap for selected projects, and a long-term service agreement. And as we today focus mainly on the wind and specifically on how wind fits into the Indonesian market. So let's go a little bit detail on that one. All right, don't you like the quote here? I really like the quote that says, nobody should ever have to choose between affordable, reliable, and sustainable energy, right? Why should you choose? Because we could have it all, right? Specifically today, but of course it depends on the specific project, site factors, and everything. So GE, we have a long history in the wind industry where we have been evolving in terms of the technology, and we have currently 70 gigawatt of installed base across the globe. From where we start with 60 meters of rotors, we are now today having one of the biggest wind turbine for onshore application at 158 meters rotors. So it's kind of amazing on how the research and development in the field has progressed. Let's zoom in a little bit to Indonesia, right? Which is our topic for today, obviously. So this is quite an interesting map. So what do you see in the map? If you ask me, right, I see a big country. From the western tip to the eastern tip, it is actually the same size or same distance between Ankara to London. With the big size itself, it also requires big energy, right? So for today and also for the future, which fortunately enough for Indonesia, we have committed to the energy mix based on the Paris Agreement. So we have to put in more renewable into the system. And also lastly, when it comes to wind, I also see that the wind varies a lot in different locations, right? With several good wind pockets across the country, by blue being the low wind speed, and the darker color, orange, is the higher wind speed. And yellow is where the speed above 6 meters per second roughly is. Well, it's a typical class 3 regime kind of market, right? I remember a couple of years back, wind was not perceived as suitable technology here, which the parameter at that time was, and it still is actually, the LCOE, right? So the leverage cost of electricity. Well, because at the time, we didn't manage to optimize the wind turbine design to capture a lower wind speed, in which in Indonesia, the market in average is a lower wind speed, right? At 6 to 7 roughly. But today we do have the right design, we do have a better technology, so it can cater a little bit on the wind source that we have. So let's walk through on the evolution and how the development in the industry has helped wind to be having lower and competitive LCOE, right? So LCOE is defined as the cost. I believe most of you know what LCOE is, but just to briefly go back a little bit on the basics. So LCOE is defined as the cost to build and operate the power generating assets over its lifetime divided by the total power output over that lifetime. It is the cost at which power must be generated to break even over the lifetime of the project. And it takes account of all of the costs over its lifetime, such as the initial investment, the O&M, the cost of fuels. Of course, it's not here the case for wind and solar, and the cost of the capital itself, right? If you see in the graph here, there are two parameters that build up wind LCOE. The AEP, the generated power on the right-hand side, basically consists of the rated capacity, the diameter or the swept area of the wind turbines, and also the load factors. And the CapEx, OpEx on the left basically consists of the lifetime of the projects, the cost of capitals, O&M, etc. So as we are focusing on the technology, let's focus specifically on the right-hand side, right? So the wind turbine technology is the primary component of onshore and offshore wind LCOE, driving both the energy productions and also the generation costs. And the AEP is strongly driven by the rated power, as you can see here, driven by the rated power and the size of the turbine. So most of the time, the bigger, the better for wind application. And over the year, the wind turbine has been increasing in terms of size or in terms of the swept area, right? As an illustration, in the bottom, you can see that for the impact, a 10% delta in annual energy production will give roughly a 9% decrease in LCOE, which is amazing, right? When you need to meet certain level of return expectation or hitting a certain tariff level in a specific country, such as Indonesia, for example, is the way to go. So the bigger the rotor, the higher the tower, if the shear is good, of course, will give you more annual energy productions. A longer assets life of your wind farm or the wind turbine will help you to reduce the OpEx. And obviously, a better or optimized supply chain will help you in improving the project as well. Let's see from the real application, right? So you can see here the amount of research and development has helped the wind turbine to grow from the year of 2004, you can see here, to the year of 2019 or 2020, where we are today. In 2004, the rotor diameter was at 77 meters. And fast forward to today, it's 158 meters. So it's doubled of what we have in 2004. And as you remember from the previous slide, the bigger, the better, right? Most of the time. So from this illustration, with the bigger size, it brings better energy productions by 4 times. And parallelly as well, at the same time, the industry has grown, right? With several countries opening for more wind technology over the years, it sort of helped in terms of creating the economic of scales and bringing a better capex for the projects. And all in all together, with the bigger size of the rotor, a better market condition, it brings down to the LCOE by 70%. So it's kind of amazing to imagine in 2004 and 2019 or 2020 how the wind turbine has evolved in terms of the economic and technology as well. So when we come back to the previous wind map of Indonesia that I've shown earlier during my presentation, there are a lot of potential wind pockets that a new technology can serve, where perhaps 10 years or 16 years ago, it doesn't make a lot of sense. But now with the right technology, it makes a lot of sense. However, of course, in identifying the right turbines, we have to take into account a lot of factors, right? The typical first questions, obviously, among many, the first is it a land constraint site? And second, is it a capacity constraint site? And third, how good is the average wind speed there, right? Among many other questions, of course. So this chart will help us briefly, very high level, to show on how the selection works on the wind turbine. So for Indonesia, we can shift a little bit to the left, far to the left actually, as the wind speed is considered low. There's a class 3 regime with wind speed at 6 to 7. And in a high land constraint, for example, quite a typical condition in Indonesia, right? We normally go with the higher power rating, in this case, 4.8 megawatt. So 1.58 rotor diameters with 4.8 megawatt. So we can have minimum number of pad or turbines for the project. But if we have a little bit more flexibility on the land, sometimes we can also explore the lower rating wind turbine, right? So obviously there are a lot of factors that help the project development to have reasonable return in Indonesia. But among the biggest factor is the technology development. So to close this, wind industry in Indonesia is suitable, and we need to work together among all parties in the industry to make sure that we can have a robust investment and business environment moving forward. So that's from me, and I'm looking forward for the question and answer. Back to you, Lynic.
Thank you very much, Arka. Yes, I think it's very interesting presentation. The bigger of course, that we have saw that the 12 megawatts offshore wind that's from GE, I think it's very impressive. Yes, and I think we're expecting that more interesting products from GE that's for the emerging market in Asia, especially as those countries has great potentials for the offshore wind development. Right.
Thank you, Lynic. Yeah, thanks, Lynic.
Thank you. Sure, and let's welcome our next speaker, Mr. Benoît Prim. Yes, it's your turn. I'm good.
Good.
Oh, I'll give the floor to you then. All right.
Okay, thank you, Lynic, and hello everyone. I'm gonna share my screen now. Yes, it looks like it's working. Perfect. So I hope the background noise will not interfere too much. So thank you everyone for joining in, and I hope everybody is safe. And okay, so let's go to today's presentation. I'm going to talk about wind farm construction and delivery contracts. So my name is Benoît Prim. I'm a technical director at SL Engineers. This presentation will focus on 3 sections. The first section is about the wind farm construction. So we'll go at a quick glance through the wind farm construction sequence. And we will then discuss about the 2 main types of contracting arrangement, and finally we will look at why choose such contracting arrangement. Wrong button. So a few words about me. So I'm French by developers, but I spent quite some time in Australia, in the Philippines, and recently in Indonesia. I've been there for 5 years, here for 4 years actually. I spent 20 years in a renewable energy project, and I've been lucky to be involved in the first 2 wind farms being built in Indonesia, the UPC 75 megawatt Sidrap wind farms and the 72 megawatt Tolo wind farm from Vena Energy. About us quickly, we are a consultancy focusing on renewable energy project in Southeast Asia, and we advise developers, owners, or financiers on wind, solar, hydro, or geothermal projects. At a glance, this is an overview of our clients. So we advised IPP developers, but also financing organization like ADB and lately Climb Capital in Singapore. But we also work with other consultancies whenever there is a match for skills complementarity. Now, about our activity, in Indonesia, I've already talked about the wind project. In Vietnam, which is a booming market in renewable energy right now, we've been involved in 700 megawatts of wind farm project as technical advisor for an investor. We've also been involved in the Ayala Energy and Beam 330 megawatt peak Nintuan solar project as technical advisor and owner's engineer during development. In the Philippines, we've been there at the time of the feed-in tariff for wind and solar, and we've been involved in many phases of different projects in solar and wind projects. Now, let's dive into the topic. So how do they make wind farms? So first, we need to build the road, the access road. This needs to meet certain requirements to be able to transport the component. And as Arka showed us in the latest presentation, these components are increasing by size and weight every year. So this road needs to allow access for the trucks to deliver the component. Then one of the key elements of a wind farm is the foundation. Nobody wants to see a wind farm, a wind turbine on the ground. So this foundation needs to be carefully designed and carefully constructed. As you can see on this picture, there is a lot of reinforcement involved, and these need to be carefully checked, carefully cut, and carefully put together. So once the concrete is poured, this is what a wind turbine foundation is going to look like before being backfilled. So the next step is we're going to put the earth and the ground back and compact it to make sure that the soil is going to be able to withstand the crane and the loads during the erection of the turbines. In the meantime, while all the roads and foundation are being built, the wind turbine are being manufactured, usually from overseas, and then shipped to the closest harbor. This one is actually in Makassar, in South Sulawesi, and this blades have been transported to the Jeneponto for the Tolo wind farm. Then the logistics consist of bringing all the components one by one to the site. As you can see, these need to have special trucks and trailers because the components are oversized and it requires some strength from the roads and the bridge, which needs to be upgraded from time to time, and to withstand the loads of the component. One of the most impressive component to transport is the blade. You can see this one. It's from Siemens Gamesa 130 model. So this blade is about 64 meter. As you can see in the background, you got some trailers. So it gives you an idea of how these blades have been transported, and this obviously needs special requirements on the roads to be able to turn, for instance, or to climb up hills if they have to. So once everything is being delivered, as you can see on this picture, then the different sections of the tower are assembled, erected, and the last part will be the hub. Well, the before last part will be the hub, and then the rotor. So for the rotor, you can see on this picture, this turbine, the full rotor has been assembled and then is going to be lifted. As you can imagine, this requires some very specific condition, and you cannot have too much wind on site at the time of lifting, otherwise it's going to be dangerous and messy. So you need to have a 4-hour window roughly to be able to lift the rotor. That's for Siemens turbine. On the Sidrap, there was a Gamesa turbine. The Gamesa turbine, they have a different technique. They use, the blades are lifted one after the other and attached to the hub directly, not on the ground. So once you've done it for one turbine, then you move the crane to the other turbine, and so on and so on. So that's basically how it works. Here, this is an image, a picture of the Tolo wind farm. The turbine was 135 hub height and 130 meter rotor diameter. Here, this is the Sidrap wind farm next to Pare. They are 2.5 megawatt each. There were 25 of these. So now talking about the construction contracting models. So basically there are mainly two options. One is the EPC, the engineer procurement and construction contract, or a multiple contract arrangement. So the EPC, when we think about EPC, usually we think about one contract with one main contractor. This is usually the case, but in Southeast Asia, we realize most of the time there are two contracts. One is an offshore contract, one is an onshore contract. That's for tax purposes. Mostly, the offshore contract is a contract for the turbine supply, and it's done with an overseas company. And the onshore contract is made with the local contractors. The contractor is going to build the road, the foundation, the internal reticulation, the substation, the transmission line. One of the key advantage of the EPC contract is there is one or say two parties to blame, and everybody's on the same boat. So if there is a problem, the contractors are all liable somehow to the owner and the financing institution. One of the key advantages is you have only one schedule to monitor and only one construction team to manage. So it's the simplest way of contracting. Now, the other option is the multiple contract arrangements. In this structure, basically each part of the project is broken down into contracts. So you're gonna have the turbine supply and installation agreement with one, will be one contract. The civil part will be another contract, and the electrical part another contract. And basically, the owners is taking the risk, is taking the risk as the EPC contractor. So he's going to have to manage all these contracts together and make sure they run smoothly. So all the contracts are independent. And for instance, if the roads are not ready, then and the turbine cannot be delivered, the logistic contractor may be able to claim extension of time because it's delayed in its execution. One of the key difference with the EPC contract is all the interfaces needs to be managed at every level, from the design, the construction, and the commissioning stages. So you need to make sure you have a robust responsibility matrix in place. Another key difference is the owner has to manage the schedule by himself. So basically, he needs to aggregate all the schedules together and find the new critical path and make sure that they all run smoothly. This, in terms of supervision, this requires also a stronger team on site to make sure that all contractors are doing the right thing and are not facing too many problems. And the owner's supervision team will have to make a good communication between the contractors. In a nutshell, the pros and cons of each structure. The EPC is seen as more bankable because the financing institution sees it as less risk, see it as less risky. You have only one contract to manage or one contractor to manage. You have one schedule and it requires less supervision. On the flip side, there is less control on the price, on the schedule, and potentially on quality. For the multiple contract arrangement is the other way around. You have, the owner will have a better control on price and on schedule, and possibly also on quality, because basically he's gonna have to manage its contract separately, and he won't be charged a markup, for instance, for this, as the EPC contractor will do. On the flip side, it's harder to project finance, harder to convince banks that it's going to be, the delivery is going to be okay, because they see that as more risky contracting structure. You have more contracts to manage. The interface is can be quite complicated, and the schedule also more complicated. To basically mitigate that risk, you need a strong owners team on site and in the back office. Now, who should choose which model? So basically, if the owner doesn't have much experience in delivering wind farm, or the market is nascent, meaning that the contractors don't know how to build foundations, for instance, maybe an EPC contract will be preferable. If the owner is experienced, has done it before, has delivered wind farm before, knows the risk, knows how to manage them and how to mitigate them, or the market is mature enough, you have many contractors that have done many wind farms in the past, then multiple contracts can be considered. But ultimately, it all comes down to the financing arrangement and what the financiers are willing to finance, basically. So what contracting structure they will favor. And if you are able to convince the financiers that you can deliver a project under a multiple contract arrangement, then you're gonna make some saving in the end. In Indonesia, the two structure worked. Sidrap has been delivered under a multiple contract arrangement, and Tolo has been delivered under an EPC contract. So everything works, and that's it for presentation. Thank you for your attention. If you have any questions, here are my details. This is my WhatsApp number and my email address. Please do not hesitate to contact me. And I'm gonna give the floor back to you, Lynic.
Thank you very much, Benoît. I think very interesting presentation. I think it's a very good presentation for the construction management and the decision makers and the developers, because the contractor setup will be directly impact the IRR for developing your project in emerging countries, especially in Indonesia, I think. And if any questions, I think you can contact Benoît, because he has been involved in the very first two projects there. So I think it's an interesting presentation. Thank you very much, Benoît.
You're very welcome. Thank you for this opportunity.
All right, and let's welcome our final speaker today, Mr. Leonard. Yes, now you have the floor. Thank you, Leonard.
Can you all see my screen now? Are you able to see my screen?
Yes.
Okay. All right. So, gentlemen, thank you for spending time to join us. I have focused my presentation on trying to encourage all the stakeholders of wind energy, as well as the policy makers of Indonesia and the stakeholders about the benefits of offshore wind. So today I'm going to talk about the technology and Asia markets development. May I continue? Hello?
Yes, please go
Okay.
ahead. Go ahead. Yeah.
All right.
Yes, please.
Okay, so this presentation is by Renewable Energy Global Solution, and my name is Leonard Yeo. We are basically based in Singapore, and we are a catalyst developer of offshore wind farm. And currently, we are very active in the offshore and intertidal wind farm in South Vietnam. For the last 3 decades, my team focus is on mega projects, and we are the first mover developers in a lot of new industry, from the marine and offshore infrastructure, and now very active in renewable energy. Basically, as a first mover, we go to the country and where the industry has not existed, and we start by identifying the projects, technology selection, identifying the financing, and we bring it through the risky construction period until operations, and sometimes even following the next 20 years of operation as an asset manager. Basically, I think my two other friends who have spoken are part of the stakeholders in this circle. May they be technology players, or may be engineering contractors. We work together with all the stakeholders to bring renewable energy to finally to the population of the country. So these are some of the projects that we did: waste to energy, waste to water for the Beijing Olympic, LNG, and for renewable energy, we were quite active since 10 years ago in Europe, helping the high performance 5 megawatt wind turbine to gain market entry and popularity. So now I have 5 topics to present to all of you. The first topic is about 2 decades of industrial developments. Basically, half of what I'm going to show you has been presented to the Vietnamese government 3 years ago. And I'm quite pleased that the industry is is gaining a lot of grounds in Vietnam. So I'm sharing these slides with everybody who is interested in bringing wind energy to Indonesia, especially offshore wind. So what many people may not be aware is that actually 16 gigawatt has been installed in water depths of 35 meters and no further than 50 kilometers offshore. And most of the players are from the UK, Germany, and Denmark. The chart on the right shows that actually wind energy, especially offshore wind, is already 20-year-old, you know. So it's nothing new or risky. Basically, what is important for Indonesia is to know that the 3 top players are either the country which has the highest number of installation, 1,700 over wind turbines in 2017 in UK, or a country which have the high performance turbine, you know, which in the case of Germany, their average turbine is 4.6 megawatt. And in the case of Denmark, their average turbines are smaller, 2.5 megawatts. What is very important is that offshore wind reduces CO2. And in most of the seminar, everybody is complaining about the price of electricity. But please, I'd like to share with all of you that offshore wind is not a cost center. It in fact creates employment for the country. And I think our friend from GE has explained about the development of the technology. The farms are getting bigger. So the offshore wind price have dropped from 15 cents per kilowatt in 2012 to below 9 or 7 cents currently. So exporting the electricity, why I call it export is because actually my pet topic is offshore wind. I'm just giving an example of the first ASEAN offshore wind in Vietnam, which is in the Binh Thuan province. There are 4 phases of 600 megawatt each. And again, this offshore wind will bring about 7.2 billion US of investment. So I hope the people of Indonesia will realize that renewable energy is not about paying for electricity. It brings investment and employment to the country. So what does it do? In this case of the first offshore wind being developed in Vietnam, actually it exports power into Ho Chi Minh City. All right. And this is a case of offshore wind production in Germany in 2017. Germany produced 13.4 gigawatt hour, which is about the same amount that is consumed by the whole city of Berlin or Hamburg, or it can even supply more than the needs of Munich. So why offshore wind? For everybody who is familiar with renewable energy and onshore wind, I'm not here to say anything negative about the other type of renewable energy, but I think this chart on the right speaks for itself. The lower boundary is the German onshore wind, and the higher boundary is the European or German offshore wind. And the percentage is the yield, energy yield. If you measure it from a wind farm, we call it net capacity factor, which means if you buy a 5 megawatt wind turbine or a 10 megawatt wind turbine, and you multiply by 365 days and 24 hours, the percentage shows the average of utilization of that turbine capacity or the wind farm capacity. So in summary, what I'm trying to tell you is that the energy yield of offshore wind is about double that of onshore wind. And these are real operating statistics from Europe. And just to give you an idea, England is an island and all the coasts are populated with wind farms. On the right-hand side, you have Denmark in the center. On the left is the German North Sea, and on the right is the Baltic Sea. And all the dark blue color shows that there are already wind farm operating there for the last 10 to 20 years. So in summary, this chart also shows that the percentage of offshore wind of total wind energy, in the case of Europe, offshore wind is about 10 to 20% of wind energy. In the case of England, offshore wind is actually 50% of the wind energy generation in UK, which is a very big island. So this has also brought about with inter-country transmission. When the wind is high near Russia, you know, the Lithuanians can be exporting wind to Great Britain, you know. So offshore wind can be transported laterally across different countries at different time zone. So last but not least, offshore winds which are high, large utility renewable energy will require internal transmission, and this create more jobs. In this case, it create more jobs in Germany. So, so basically, what am I trying to say is why now? Why now? Basically, the world population is very large, right? And Indonesia is the 4th largest population. So you have a large population, young, vibrant, and economy driving for energy demand. One thing I like about wind, whether onshore or near or offshore, is that it has a very high local content during the construction and during the 20 years of operation. And last but not least, is a low-risk maturing technology and industry. So as what GE has already illustrated, technology drives down offshore wind electricity. Not only the wind farms are getting bigger from 150 megawatt to 1 gigawatt because the individual turbines are getting bigger. And therefore, the levelized cost of electricity for offshore wind is now as good as the price of coal or gas or even nuclear power plant. So why Indonesia? Let's look at who has entered the offshore wind industry. The firemen in Europe do not want to be firemen anymore because they are very busy, you know, installing offshore wind and doing operating and maintenance. And many companies in the offshore oil and gas industry are now in the offshore wind industry. This is a famous Irish shipyard, Harland and Wolff, which built the Titanic. In 2008, they are very busy building foundation for the offshore wind. These are European, Norwegian, and German yards in 2010. And these are Middle East yards, and they are all busy building foundation for offshore wind. This is Keppel Shipyard in Singapore. And 5 years ago, they are busy building an offshore wind installation vessel. And even another shipyard in Singapore are building offshore substation for European. So this is my last few slides. In terms of Asia, China have already, People's Republic of China have already installed offshore wind farm in 2010, followed by Taiwan 5 years ago, in Japan last year, Korea, Vietnam the last 2 years, Australia on the west coast. So in Indonesia, it's a question of when, you know, not why. So this is my last 2 slides. Offshore wind farm can contribute to Indonesia large-scale utility power generation to meet renewable energy needs. The Indonesian regional and local onshore and offshore infrastructure and energy supply chain has the potential to support Indonesia offshore wind industry. And remember, for every 100 million you invest, 60% have local content, which means it creates jobs, you know, and generate revenue for Indonesia. So a typical 600 megawatt offshore wind farm not only costs typically 2 billion, but every year for the next 20 years, it requires 70 million of operating and maintenance. So this is what is the message I want to leave behind. And I'd like to show you this map. In Southeast Asia, Indonesia is the world's largest archipelago with more than 16,000 islands. So every time you have an island, you have waters around the island. So I have this dream that Indonesia will be able to start a new energy with offshore wind. So thank you very much, and that's all I have to share with you today.
Thank you very much, Leonard.
Okay.
Thank you very much. Yeah, sure. I think it is undoubtedly that offshore wind is the trend is in future wind development. I think we have big potentials in Asia Pacific nowadays, and we are welcome more experienced developers and technology, also service providers, to help the countries and help the regions to develop together. Yeah. Meanwhile, thank you very much for 3 speakers today, and I think we have collected lots of questions, of course, from the floors and from the pre-registration. And I am afraid we may not able to answer all of them today, but I will pick up some. I think the first one, let's go to Arka. I think you are very popular in the Q&A sessions now. How is the potential wind projects in Indonesia? Did you see the positive trends? Yes.
Yeah, that's good to be popular and be asked questions. I wasn't popular in school, so it's good to be popular now. Just a quick one. If I couldn't respond on the questions, I'll drop the email, Lynic, and the participants can connect me directly. Lynic, I'm okay with that as well. In terms of the potential for onshore wind, I think Benoît and Leonard can add up as well later if you have. In terms of the wind resources, right? In terms of the wind resources, we do have a good wind pocket all across Indonesia. The question is now whether the wind resources is located at the right grid, right? Whether there's load in the locations, whether the grid is going to be ready to accept that size of a wind power plant that we are thinking of. But to answer the questions, yes, the potential is good. If we see on the RUPTL, at least the latest RUPTL in 2019, there's at least 1 gigawatt for the next 10 years for the wind itself, right? But of course, we need to wait for the new updated RUPTL that is going to be revised based on the COVID situations. But in terms of the potential, it's going to be there and it's going to be big as well, Lynic. That's from me.
That's great. And yeah, I think also when mentioned RUPTL here and the questions is land acquisition is an issue that we also heard from the last webinar from UPC. So is it still an issue that with PLN and RUPTL to put the towers in the potential areas? The land acquisition.
You mean sorry, I didn't get that. So the land acquisition, what was the question?
Yeah, is the land acquisition an issue with PLN, RUPTL to put the tower?
You mean to put the tower from the developer side, is it?
That's correct, yes.
Yeah, I think depending on where you are, but typically if you're in the big islands in Indonesia, say Sumatra, Java, Sulawesi, and Borneo in Kalimantan, some area, yes, you might have difficulties in the land acquisitions, but I believe most of the case for other developers, they also have the ability to do it. So I can say that there's a challenge, but there's a way out to do it as well, in order to achieve that.
That's great, thank you. Sure, let's move on to the next one to Benoît. How feasible wind turbine in commercial and the business aspect? What do you think in Indonesia?
What do you mean commercial and industrial? So do you mean to sell wind power to commercial and industrial entities? Is that the question? Actually, the only entity we can sell power in Indonesia is PLN. So we have to sell electricity to PLN, and that's why we need power purchase agreement with PLN. So far, there've been 2 signed for wind, so the Sidrap and Tolo project, and hopefully there will be some more soon, but we don't know exactly when, because there is a feed-in tariff, I understand, regulation, which is cooking, but it's going to be up to 10 megawatts. So 10 megawatts of these days, maybe 4 turbines or something like that, 3 or 4 turbines. So it's not going to justify a utility scale project. I mean, the substation, because of the substation and transmission line. Above 10 megawatt, I understand, is going to be a tender, is going to be tendered. So then it's, or even a one-on-one. Currently, it's one-on-one. So it's a one-on-one negotiation with PLN, and the tariff is agreed obviously privately, but between PLN and the developer based on the project specificities. So maybe the regulation will evolve, and maybe actually it's more like an electricity market structure that will be needed to change that, because yeah, again, right now only PLN can buy electricity and sell electricity.
Right, and I think we also have one question from the floor to Benoît. Is in the first 2 projects in Indonesia, what do you see the biggest support from government so far?
The biggest support?
Yes.
I think from the top level from the government support is been well supported, and after you have like everywhere you may have some challenges, local challenges every now and then, but altogether I think this project have been very well welcomed, and they proven that they can support the local community, and they make Indonesia actually a better place in terms of CO2 emission savings, because you displace 88% of the electricity in Indonesia comes from fossil fuel. So the more wind farms or solar farms you add, the greener the electricity is.
Great, thank you very much. And let's move on to the third one. What is the minimum wind speed for the approximate capacity? And also, I think the question is regarding that hybrid, the wind plus BESS solutions. Is it potentially that's feasible in Indonesia? I think, yeah, Benoît, maybe you can share your...
I mean, for the wind speed, maybe Arka will be better spotted to answer, because he knows the turbine more than me.
Of course.
But for yeah, the addition to add the BSS, it's a trend actually going on in Australia, for instance, because it's helped mitigating the intermittency nature of the wind power project. So yes, it can be done. The thing with energy storage is not cheap. So after how is this energy storage is going to be valued is another question. But I'm sure if the right market environment is there is something to dig. Yes.
All right, great. Arka, I think you know better about the speed.
I think in having a feasible project, there's a lot of factors kicking in, right? Of course, the total cost of the development will be one in terms of how you acquire the lands and also doing the studies and everything. When it comes to wind, at least today, as a rule of thumb, low six will be good already for Indonesia with the current turbines that we have. But again, that it also depends on how much the tariff is in the locations, how much capacity that you can inject to the grid. So there's a lot of things coming in, but I can say roughly low six should be okay.
All right, okay. Well, so do the systems of PLTB Sidrap has a smart grid? Yeah, gentlemen, do you have any comments on that?
So I'm not sure actually, as there is obviously some SCADA and regulation to control the output of the wind farm. Now, how does that fit within a smart grid technology? I'm not sure, but basically a PLN can see exactly what's happening and can ask to reduce the power if needed, but I'm not aware of such requests so far.
Okay, great. Any gentlemen want to share your comments on this question? If not, we will go to the final one. What is the current technology to handle the intermittent of wind power? Yeah, Arka, you have any comments on this?
Yeah, you like it or not, wind power plant and solar power plant is an intermittent technology. But again, depending on the grid study that you'll be having at a later stage, but at the moment, battery storage to help the ramping up and ramping down of the power plant will be helpful. And if I'm not mistaken, the past couple of RFPs that was out from PLN, you can correct me if I'm wrong as well, Benoît and Leonard, they also required battery to be considered in the system. So you design the wind power plant together with the battery storage to help on the intermittency of the wind power plant.
Great. Benoît, you have any comments on this?
No, I think Arka answered the question. I mean,
all right, okay.
Yeah, battery storage.
That's great. Yeah, sure. So I have a final one for Benoît that's from the floor that's regarding the wind blade design that could produce high efficiency wind energy based on Indonesia characteristic. What is your opinion regarding the wind blade design?
Actually, I think it will be a good question for Arka because
Okay.
that's a technology then. But in short, yes, the blade design is very important and is a key to the output of the turbine. There are a lot of studies going on on the blades, and I think the latest GE turbines actually come in two sections. Am I correct? The latest blade for the 158.
Yeah, correct. So we have the split blade. So thanks, Benoît, for answering on behalf of GE. So it's a two blades. One blade we split it into half, which obviously will also help in terms of the logistics and supply chain, which Benoît and Leonard has discussed about this as a challenge as well in the project execution. So yeah.
Great, thank you very much. I think we have, I'm sorry that we have so many questions also in line, but we are not able to answer all of them. But I think you all have the contacts from our three speakers, and feel free to be connected with them, I think on social media by LinkedIn, or you can send email to us, and we are happy to connect. And thank you very much for joining our today's webinar, and thank you very much for all the contributions and sharings from our speakers today. And also thank you very much for the audience for spending time with us, and hopefully that you get more insights. And I'm sure that we are all here to help the countries for Southeast Asia, for Asia to develop the wind market together. And hopefully we will see you soon. And happy to introduce our next one on our webinars for the Vietnam wind energy. That's on 22nd October, 3 p.m. local time. And we will have more heavyweight speakers also sharing the latest updates and also future of Vietnam wind energy development. Yeah, we are also very glad that we are also launching the wind map for Vietnam. And we'll have illustrate the latest projects information for you to find. And we are also calling for, we're also calling for that advertisers maybe who are interested to supporting this maps. And also we will have happy to share more projects if you can share us the latest information as well. Thank you very much for attending today, and thank you very much for Arka, Mr. Benoît, and Mr. Leonard. Thank you very much.
Thanks, Lynic. Thanks, everyone.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you. Thank you. Thank you. Bye-bye.